Welcome to Module 3, where we will finally delve into the world of 3D modeling. In Module 1, we have covered the basics of flat surfaces and edges. Now, let's talk about how SketchUp handles 3D surfaces and edges. To begin with, I will demonstrate by drawing a simple rectangle shape. To understand the construction process, I will start by creating lines that extend along the blue axis. To lock my direction, I simply click the up arrow, and then I can put any desired value. Next, I can lock the line on the red axis by using the right arrow key. I hover over the bottom point to match the length of the bottom line. Once I close the loop, we have another vertically placed 2D surface. We repeat the process for the remaining surfaces and combine them all. Alternatively, we can also use the rectangle tool to achieve the same result. When the last surface is combined, SketchUp automatically generates the top surface for us. In total, we now have a 3D box composed of 6 faces and their connecting lines. Removing a line would also delete the surface that depend on it. Similarly, deleting a surface would create a 3D shape with a missing face. Fortunately, we don't have to manually draw all the lines and surfaces because SketchUp offers a powerful tool called Push-Pull. You can find it on the left toolbar or by pressing P on your keyboard. Let's go back to our flat rectangle. Select the Push-Pull tool and simply hover over and select the surface we want to extrude. By moving our mouse up and down, SketchUp automatically generates all necessary surfaces and lines. So we can enter the desired height and press Enter. Additionally, we can push-pull from the sides to further extend or retract our object. To gain insight into the internal structure of our 3D object, we can activate the X-ray view, which allows us to see through the object. Doing so reveals that the object is completely hollow on the inside. X-ray view can be helpful when examining an object's construction. I could now divide each surfaces using lines or create further flat shapes on the surface and move them in or out. Now let's remove one line, as it could happen by accident to anyone, and see how to fix it. Once removed, you can see inside the 3D object, but my surface is missing. So how do we get it back? In order to create a surface, you need to see if one line is somewhere missing. So in this case, this straight line that combines the whole structure in order to create your surfaces is missing. So let's put it back. What it also does now is creating a new surface on the area where I had my window, and now it's suddenly merged with the whole wall. It happens as SketchUp likes to create ingeniously surfaces even though we might not want them. In order to fix this now, I have to tell SketchUp, please divide this area again, and by doing so we can redraw the window using the rectangle tool and simply remove the face. What is important to mention is that if you create multiple objects that you would like to move freely around, I recommend creating groups whenever you feel the object needs to be separated from the rest. If I was to move this object now, selecting its 5 surfaces and start moving it, it might work if you are on the same height, but if I was to move it up or down, you can see that the bottom lines are attached to the top surface. To avoid this, I should have grouped my whole object before creating another rectangle, which I also group. Then I can move it freely around. If I was to change something within my grouped object, I have to double-click to go inside my group, and with Escape, you can leave the group again. Always ensure that you are working within the correct group. It's worth noting that drawing a line outside the group won't have any effect on the selected object. If you want to make changes to a grouped object, you need to go inside the group and start making your changes. Lastly, I would like to mention that you will come across objects that have multiple groups within one main group. This is usually the case when downloading 3D furniture from the SketchUp warehouse. So in order to be able to manipulate those objects, you need to go inside the main group to see if it consists of further groups. This way, you can go deeper and deeper into the levels. Grouping is crucial, and in the upcoming videos, we will explore when it makes sense to group objects. And we will definitely see groups within groups when we start building our custom-made wardrobes. Alright, now it's your turn to experiment with the push-pull tool, creating shapes, removing lines, and fixing missing surfaces. You can also start creating some 3D groups, which can be moved freely. In our previous lesson, we have explored different techniques for organizing geometry in SketchUp. We have discussed the importance of using groups as a way to keep things organized. However, there is another option we haven't explored yet, and that is using components. Today, we will compare all three options: open source, groups, and components. To help us understand the differences, I have created 3 rectangles using the open source method. Now, let's move on to creating a stair shape using the push-pull tool. Once we have our first stair, we select the whole object, and then we can make copies using the Move and Copy function. Remember, you can also use the shortcut we have learned earlier by typing in the star and the number of stairs you need, and pressing Enter to create your copies. So now we have an open source staircase where each step sticks together. There are some limitations to working with open source geometry. If we want to make changes to just one step, it affects the connecting lines and surfaces as well. This lack of flexibility can be a bit challenging. That's where groups come in. Let's build the same staircase, but this time we will group the stairs before making copies. After creating our first stair, we can select it and create multiple copies again. This will give us a grouped staircase where each stair can be moved independently. Although we could group all the stairs into one main group by selecting them all, let's leave them ungrouped for now. Lastly, let's create another stair and selecting the entire shape. And instead of grouping it, we will right-click and choose Make Component. We will give our component a name such as stair and skip the other options for now. These additional options are more relevant when sharing files through the SketchUp warehouse or providing additional information. Now, let's compare the open source geometry, grouped objects, and component objects. With the open source geometry, everything is interconnected and sticky. Modifying one part can affect the connecting lines and surfaces, making it challenging to make individual changes. In contrast, the grouped stairs provide more flexibility. Each stair is contained with its own group, allowing modifications to be made independently without affecting the others. Lastly, let's have a look at the component objects. Components act as clones of the original object. When changes are made to one component, all its clones automatically update. This means that modifying one component stair will result in changes being applied to all the clone stairs. To summarize, open source objects are sticky and not very flexible when it comes to changes. Groups maintain individuality within their respective groups, while components act as interconnected clones. So, when to use group and components? Groups are very often and commonly used, and it's a great way to be able to separate different objects or areas from each others. Components can be useful when creating multiple identical objects that require simultaneously modifications, such as windows, doors, or stairs. I usually use it for doors or a staircase, like in this example. In the case that for some reason you need to isolate a component from its clones, you can select that particular component and choose Make Unique. So changes made to this specific component will only affect itself. But when we copy this unique individual component again, you create another clone and it retains its association with the original unique component it was created for. Hope that makes sense to you. Personally, I tend to avoid working extensively with components because sometimes I may forget to make them unique before altering a window to a different size. This oversight results in unintended changes to all the windows. However, if you find a use for components, feel free to incorporate them into your workflow. SketchUp models can become heavy when they contain numerous unique geometry instances. By using components, you could potentially reduce your file size as instances of the same components are stored only once. This optimization helps maintain better performance, especially when working with large and complex models. To view all the components in your model, you can click on Window and select Components. Here you can find our stair and the newly created one when we clicked on Make Unique, as it kind of creates a new component from it. We will come back to this window at some point again, just so you already know where to find your components. Remember, while components may offer many advantages, it's essential to use them appropriately. They can be ideal for objects that have repeating or modular characteristics required frequent editing. By understanding these distinctions, you can choose the most suitable option for your project. Now it's your turn to experiment and create a staircase with multiple stairs using open source stairs, grouped stairs, and component stairs. You can also try making one of the stairs unique and see how they behave once you make changes to it. Now that we have a good understanding of how SketchUp constructs its 3D models using surfaces and edges, Let's move on to building the 3D walls based on our created floor plan. In this process, I usually prefer to work with a separate file for the 3D visualization, keeping it separate from my 2D spatial plan. The easiest way is to simply copy the 2D file and rename it into 3D visualization. However, this approach is entirely up to you and your personal preference. I find by keeping the floor plan and the 2D model separate, I can maintain a cleaner and more organized workflow, since I may want to include additional scenes or layers for certain purposes that might interfere. We will talk about scenes later, close to the end of the course. So, for now, if you feel like, just go ahead and make a copy of your 2D floor plan that you have already drawn and rename it, or just use the 3D framework file, which is included in the Module 3 zip folder. As you can see here, I have built up two different frameworks. They look the same at the first glance, but they have a difference. Let's turn off the spatial planning layer for now, as we don't need it for some time. So in the past videos, you have basically seen two different approaches. Framework 1 should be the result that you have gotten, meaning you have created walls and windows together, and then you started grouping the windows. So the space underneath will be cut out from the floor and wall surface. This is usually the way I build up spatial plans and use them later for 3D. Now, what I also see many times from other designers is they create the walls first, and then they group them, and then they create the windows and group them. You may be more flexible in moving around windows, but other than that, I don't see the benefit from doing it this way. Let's start building our walls from this drawn floor plan and see the benefits and disadvantages. Before we start building our walls, I want you to open the PDF plans from the Module 1 zip file. We can see that our internal ceiling height is 2700 millimeters or 106.3 inches. Let's go back to the framework file. Since this file is a copy of my spatial plan, I can now simply use this framework I have created to build up my walls. Let's go inside my walls and floor group that we have created and double-click to go inside. Then I simply select the wall surface and press P for the push-pull tool. We know our ceiling height and simply type in the height we need and enter. We can then double-click on the remaining walls as SketchUp saves the last height that we have used when using the push-pull tool. If it doesn't work for some reason, just type it in again, or use the walls that you have already built as a guide by hovering over the endpoint. Sometimes there might occur some straight lines like this, depending on if you have used lines or rectangle tools when you build this structure. We can just delete the lines to keep it clean. We now have our wall frame. By escape, we can leave the group. Just to see the difference, we will do the same for framework 2. You can immediately see the difference in the build. We don't have any door or window cutouts in framework 2. So let's build a cutout for a full height window and one which has a wall beneath to see how we would approach this. I chose window G and window J for this example. Let's start with window G. Depending on if your window goes literally to the edge of the ceiling or if it has some wall above, you can either keep it open like this if it goes full ceiling height, or in this case, you can see that we only have a window height of 2500 millimeters or 98.43 inches. We can now use guides to mark this. Or we simply copy the bottom line with a locked blue axis and place it as its height. I usually copy the lines, as I won't need to draw a line when using guides, but both approaches work. Then you simply push-pull the wall and use the interferencing endpoint like this. If the lines bother you, you can just remove them. Let's do the same for framework number 2. If we want, we could turn on X-ray mode to see better where our window is placed. We could now create guides for our cutout and then use the rectangle tool. Now we can push out the newly created cutout and hover over an endpoint again. It can happen that by accident maybe you go a little too far and then your wall is kind of extruded. So in this case, just go back and try it again until you selected the correct endpoint and you can see through your wall. I find it easier to work with framework number 1 as I already have my cutouts and I just need to add the walls I need above or below the window, but you can do it both ways. Creating window J is very similar. Let's check the measurements. Height under the window is 1090 millimeters or 42.92 inches. Window height is 500 millimeters. Height above the window is 1110 millimeters or 43.69 inches. Just rechecking. Then I just push-pull out the walls. And that's done. Let's do it for the other window in framework number 2. And now you can see I forgot to do it within the same group. It can happen sometimes, and if you see that nothing is happening, you cannot push-pull out or in that wall, it means that you are not in the group. I simply now can triple-click on all my surfaces and edges that I created, and then press Command X or Control X to cut it out. Then obviously I go inside my group and use Edit, Paste in Place. Now I can just push-pull it out again. Both approaches work, but I do prefer to work in framework 1, since I already see where my window is and this way I don't forget a window or a cutout. That's it, it's really that simple. This way you can push pull out, in and in, whatever you need. Okay guys, now it's your turn to finish this framework and create all cutouts for the windows and doors. It doesn't matter if you prefer to work with Framework 1 or Framework 2. Hey everyone, now that you have completed your framework, let's focus on creating the arched openings. To begin with, you can consider placing your 3D walls on a new layer, named 3D walls, if you're working on the same file as your 2D spatial plan. This allows you to easily turn off the 3D walls layer if you need it. However, keep in mind that working with too many layers can sometimes lead to confusion. Remember that even a single line can end up on a different layer if you forgot to click on the pencil when making changes within the layer, causing you to draw on a separate layer. In such cases, you will have to reassign the line or use the Entity Info option. Overall, I recommend avoiding overcomplicating things with layers unless you are working on a large file with multiple floors. Ultimately, it's your decision what you choose to place on different layers. Now, let's move on to creating the arched openings based on our Eden Springs floor plan. I prefer starting outside the wall group to maintain flexibility and moving the arch. As you know, within my group, everything will stick together. We have previously set the openings for the doors at a height of 2200 millimeters or 86.61 inches. Let's create a guide for this. I will then Select the 2-point arc tool and increase the number of sides. Remember, the more sides you have, the rounder your arch will be. However, avoid going overboard, as more sides result in increased information that SketchUp needs to process, potentially impacting your performance. Let's choose 40 in our example. I will click on the left and right points. Then I move my mouse along the locked blue axis upwards. Here, I will choose the bulge value, which represents the distance from the bottom to the top of the arch. I can now freely move this line to the desired height, aligning it with our guide. Remember to lock the axis with the up arrow key to ensure the line moves down correctly and doesn't shift to the side or to the end. Once the height is set, I will complete the upper surface by adding a rectangle shape around it. Be careful to select the correct endpoints. Afterwards, I can remove the bottom line, so I only have the upper surface. This is what I need. To finalize my arch, I triple-click to select all connected surfaces and edges of the shape and press Command or Ctrl X to cut it out. Then I click inside my wall group and paste it in place. The only thing that's left to do is push-pull out my surface and remove any excessive lines. Note that the bottom line should not be removed as it holds the arch together. If you find the bottom line distracting, you can click right on it and select Hide. Should you want to view the line again, you can go to Edit, Unhide, All. You need to be inside the group to use this function, as if you try to unhide it outside the group, nothing happens, as this information is stored inside the group. Finally, let's move on to the other arched opening. This opening is wider than the previous one, so the same bulge value may not yield the desired results. You may need to increase the bulge slightly. Just make sure you stay within the opening and don't extend beyond it. Repeat the same steps as before. Create a rectangle, remove the bottom line, triple-click to select all connecting surfaces and edges, cut it out, and paste it inside the wall group. Finally, use the push-pull tool to extrude the shape and clean up any excessive lines for a neat appearance. There are multiple ways to create an arch or any shape that you want, and this is just my preferred method for achieving clean and round arches. Feel free to experiment with SketchUp drawing tools to create the surface you want and just pull it out. Now it's your turn to create those arched openings within your framework file. In this video, we will be diving into the process of building windows and applying textures to the glass pane. We will focus on window G for now. To maintain consistency throughout the project, I have chosen a frame thickness of 50 mm or 1.97 inches. However, feel free to adjust this measurement according to your preferences. Keep in mind that when it comes to representing windows in general sense, exact measurements aren't always necessary. As long as the overall appearance convey the presence of a window, you can stick with your standard measurements. Let's get started by constructing the outside frame before moving on to the rest of the window. We could potentially use the surface we got from the 2D spatial plan, but it's not 100% necessary. You could simply also just use this as your reference and create another rectangle outside of the group. In this example, I will use the existing surface we have from this symbol. We double-click into the group and select the outside frame surface. Then we use our push-pull tool and hover over the endpoint and release. Then I select my left window frame from left to right, as this will only select everything that is included in my selection. If I select from right to left, it also selects the bottom lines, which I don't want. Then I group this part and copy this object to the right side, as it is identical. I could use my flip tool to flip it, or if you work on older SketchUp versions, you can use the right click and flip it in the correct axis. Then I copy this frame again, move it to the middle, and use my move rotation function to move it horizontally. I place one corner next to the left frame, and since it's a rectangle shape, I can easily use my scale tool to make it shorter. Make sure to select the middle point so it doesn't scale it thinner. So midpoint, and use again the snapping function to one of the corners. Lastly, I copy this again to the top and do it the same way. Note that we are still working in the window G group that we have created back when we created the spatial plan. Now let's have a look at some more details about this window. It is horizontally divided with one plain fixed window and one louver window. So it has a horizontal division. Let's see where it is. The plain window without the frame is 1750 millimeters or 68.91 inches high. Let's place a guide there. Please always make it a habit to lock your axis, as it can easily happen that you will create a guide somewhere else. Then I select the bottom left point of my frame and copy it to the end of the line. I recheck the remaining height. It's 600 millimeters or 23.61 inches, so that's correct. What I also could have done is selecting the bottom left corner and move it up, but I would have to do some math here and add my frame height, so it is 1800 millimeters. I like to trust the guides, as some mistakes can easily happen there. Now that I have my frame, let's create a basic glass pane by using the rectangle shape. Since I grouped my frame, I don't have any issues with this surface sticking to the frame. Now comes the fun part. We click B for bucket or select the bucket tool from the left toolbar. You can see that immediately another window appears, or if you work on the windows, it automatically opens up. This window will always appear if you click on the B shortcut, which is very useful. So anytime you close the window, don't worry, it can easily come back once you click B. You can also find it on Windows, Materials. So colors or materials is literally the same thing. It might look different if you work on a PC, but still your window will open automatically. You have some options to choose from. Let's, for now, click on the right brick or select it from your selection if you work on a Windows. This will open your texture palettes. There are many materials to choose from. And for now, I don't want to overcomplicate things for you, as we will discuss materials in full detail in some other videos. Now, just select Glass and Mirrors and choose the translucent glass gray. You can see that it's selected as it will appear on the bottom left corner. Go back to your window and simply click on the surface. Let's triple click now and create a group. Let's go back inside the glass group. Remember, we are now inside a group of a group. If you can select a single surface, it means you are in the correct group. We select the panel, push-pull it out, and let's say we make the glass 5 mm thick, or any desired glass thickness that you would prefer. Then I leave my glass group, and I'm back to my general window group. Now I realized that my tint is a little too dark, since now two translucent fronts kind of merge together optically. So I use my B for bucket, and I can just change the opacity of the glass material. Now, when I try to add the material to my glass panel, you see that nothing happens, as I really need to go inside my group again until I can select my surface. And instead of having to colorate each surface by itself, there's an easy trick. If you press the Shift key, you can see 3 little squares appearing. This means that SketchUp will apply the whole material on all surfaces within this group. We can then leave the group and copy this panel again if we would like to have a double glass window front. You don't have to work with 2 panels. If you just need 1 panel, that's fine too. It's up to you on how you construct your windows. I choose this only for you to see some more features. So I didn't specify the Louvre panel height, but let's say it's 100 mm or 3.94 inches high. I could create it from scratch using my rectangle tool in the same way, but let's copy the panel we already have, as we won't need to push-pull it out and then apply the same material again. We just need to adjust its height. We could use the scale tool to move it down a bit and use a guide to tell us where our 100 mm or 3.9 inches is. Then we push-pull it down. Now, as we have a repeating panel here, we could make use of components. Let's make a component out of this panel and call it Louvre Panel Window G. There's one important thing to mention here. If we start making clones from it and start rotating its opening, you will see that it only applies to this specific geometry. While it works changing the surface and rotation doesn't work, it's merely because SketchUp need to know the direction that is applied to it within its component. So right now, you kind of rotate the outside shape. In order to be able to rotate all clones simultaneously, you need to create something that SketchUp can work with. So before we copy those component panels, we have to go inside our component, create a group within its environment, leave the component, and then start copying the panels. Now, if I want to rotate my component, I have to go inside my component, and since it's a group, nothing sticks together here, as otherwise all the components will be lined up together and they merge together, so we have to group them. So this way we can just use the rotation tool and all of my clones simultaneously move. You could obviously work with grouped objects merely and rotate them one by one. But again, it's the flexibility that components give you in case you need to change something, and also the storage, as this panel is only saved once, which will improve my SketchUp performance. Okay guys, feel free to watch the next full video where I create all of the remaining windows step by step. You can practice creating as many windows as you like until you feel confident. If you need to recheck something, you can always have the option to open the completed framework file. So in this video, I'm basically going to show you a quick time-lapse video of how I created all the windows in the Eden Springs house. And yeah, the first thing I did is copied the window G. And here you can basically move the outside frame and start adjusting single groups or single frames that you can use based to the specific size. You can also adjust the upper and lower window frame to make it fit to the actual measurements. Whatever you can copy, try to copy to save yourself time. Now what's left to do is to adjust the bottom size, copy it to the top, and here we have the adjusted frame already. Now we can just adjust the panel sizes. And since this one are components from the previous video, we need to make them unique in order to adjust them, as otherwise we would be also adjusting window G. So I'm just going to rename it. Just copy it to the bottom. Remove the other panels. And then adjust my size. And now we can use the multiple copy function with the star. Here we have the adjusted window eye. Just move it back here in the front. Now let's create window H. This is kind of split. We have a door on the left and a window panel on the right side. So I'm gonna leave out the door for now and just create window H. So create a frame, copy the frame to the side. So whatever you can make use of, just try to copy. And it's always important to lock the axis to help you with the location. Be careful when scaling. Always scale from the middle point. So now let me group the frames. Toggle inside. And now we can create our window panel. And then we can fill the panel with a transparent gray. Extrude it a bit and group it. Now make use of the interferencing tool, basically snapping onto the point that you have close by. Okay, now window F should be fairly easy. You can just copy parts of another window, place it with Ctrl V. Here the same again. Now, window F is a little special because it is basically one big window, but it has a division in the middle. So that's why I defined the midpoint and placed the middle panel, in the middle area to be able to create one single window which has two panels. Obviously, you have to define or decide yourself if it's going to be faster to make use of the windows that you have or create the window from scratch. But in most cases, it's better to copy what you have already and just adjust it. Now the same again, we need to make this panel unique, as otherwise we would be adjusting the other window from which we have copied it. Adjust the property name, and if for some reason you are not so sure if you have basically adjusted that panel, you can always open the entity info where you can see under the definition which kind of component that is. So then you know. Okay, we need to delete those and just make copies of this panel. Let me turn on X-ray to see if there are any hidden. And just select the panels and adjust the size. Now we can copy everything but the middle part and the outside, and copy it again. That's it. We want to change the direction of the openings. We can do so by just selecting one of the component panels. And since they are all copied, we can simultaneously open the window if we want to. Let's copy this window to window E. Since it's very similar, I don't have to adjust much there. So as you can see, basically it's always the same process. So if by now you know how to create those windows, just feel free to skip. One additional point I'd like to emphasize is that you're not limited to working exclusively with components. It's entirely feasible to construct these windows using straightforward groups. My intention was simply to illustrate the purpose of components and highlight instances where they prove beneficial. Now I will just continue creating the windows. The process remains the same. You're welcome to stay along or start practicing creating your own windows. In today's class, we will create the internal doors for our Eden Springs project. To start with, let's create the outside frame for our doors by creating a rectangle over the empty space and use our offset tool to offset our frame by 50 millimeters or 1.97 inches. Then we move the bottom line down as we won't need it. We remove the inside of our frame and we push-pull out the frame to the correct thickness. Usually, frame stick out a bit. Therefore, we need to push-pull it out to your desired measure. In this example, I choose 25 millimeters or about 1 inch. For the other side as well. Then I select everything by triple-clicking and create a group. As you can see, I have selected all surfaces and edges, and nothing is left behind. Let's now create the door. We are drawing another rectangle and push-pulling it to a thickness of about 40 millimeters or 1.57 inches, but it's up to you if you prefer a thicker door. Then I group my door and I can move it more inside as well. To create my door handle, I measure a height that is about 1080 millimeters or 42.52 inches, which is usually the standard height in which door handles are placed. You can obviously adjust that as you prefer. Then the midpoint of my handle is located approximately 80 millimeters or 3.15 inches from the edge of my door. Let's create the handle now. You don't have to use the same measurement. Feel free to adjust it or find some door handles within SketchUp Warehouse to download and place inside. You can see that I always try to group the objects separately from each other. This way, I can be flexible in moving them around. It helps to lock the axis when moving too. Finally, we can group our handle to be able to move all 3 objects to the other side of the door. Use the flip tool to flip it correctly. It might take some adjustments until you have this selected correct flip axis. Always use endpoints as your reference. Now we can group the whole door. Remember, you now have groups within groups. We could also open up our door. Finally, we create another main group and create a component. Since the new component is saved within our file, we can easily click on it and use it for the rest of our doors, as they have the same size. And this is what I meant in the previous videos, that SketchUp now only has to save one component for the doors instead of 3 identical geometries. Now that they are components, I can easily adjust all doors at the same time. How about we change the color for our handles into black? Don't forget to go inside each single group, and by escape, you leave the group again. So let's toggle inside the group. Colorate each part I want to colorate, leave the group, and so on. As you can see, all handles have been adjusted. This can save time. If you prefer to work with tags, feel free to create the necessary layers and use the tagging tool to place them on the correct layer. You can always turn the layers off for easier workflow. Okay guys, feel free to recreate this internal door, create a component, and place them 3 times within our house. In the next video, I will show you on how you can work with doors from the warehouse and make them work for you. See you! Hi guys! Before I show you on how to make use of the SketchUp warehouse, let's create a frame for the front door in the same way we have done for our internal doors. Again, I always like to choose a consistent frame thickness, as usually doors are only for visual purposes. If you need to create a custom-made door, which will be produced by the carpenter later on, obviously you need to adjust the frame thickness regarding to the standards of your carpenter. Okay. Let's now copy the finished frame with Command-C for Mac or Control-C for PC. I have already created another window. As you know, I like to use another file to not mess up with my original file when working with the SketchUp warehouse. You can also see that I already downloaded a couple of doors to choose from and placed them in a row. Then I paste my copied frame with Command-V or Control-V. Let's use the first door and have a look at how this was constructed by toggling inside the groups. It obviously is a component, as you can see it appears under Components. Usually, I never use the frame of the files I get from the warehouse, as again, I like to use a consistent frame size to make things easier. You could use Command or Control X to cut it out, or just copy it. Once pasted, I can combine it with my door frame and use the scale tool to adjust its width and height. If you don't mind the distortion here, that's fine, as doors are just a visual add-on and usually don't have to be exact. I would like to show you on how to select a foreign material. When opening my colors using my B for bucket, there is a little pipette below. If you select this pipette, it selects all colors you can see within your monitor. But this is not what we want. We want to select the material, and by simply holding down Command using your bucket tool, you can see that a slight different result will appear. You now chose the material and not the pixel color. Even though it's also a pipette, it's still a different selection. We can now select our frame and colorate it with the chosen texture. What's important to mention is, if you open your components list, you can find all components that you have downloaded from the warehouse in this file. And here's the thing, if you remove the object, the component still remains within your file, which can really slow down your performance. Therefore, we could use the button Purge Unused, and then it will be gone forever. Now you know why I like to work in a separate file. Imagine all the amount of components you may save in your file, and every time you try out another 3D file, you would have to always click Purge Unused, and that can be a little annoying. Okay, now my door was originally copied from a component, right? So it still has the connection to the original component, as it's a clone. To remove this connection, if you would like to, you simply click Right Explode. Then we need to also remove the original old component. Let's see if it worked by removing unused components. It's still there, so we might have to do it again. Somehow there's still a connection. Now I do have an open source for my door, but that's okay. I can just regroup it again by triple click. Let's see if it works now. Oh, Control. Looks like it still has some sort of connection. So let's remove the whole component altogether. As long as your object doesn't disappear, it means that the connection is gone. Now what's left to do is adjusting the back side of the door, as it doesn't have the handle or the same profile as the front. I could copy the door and place it behind. If it's just to visualize the door, that's fine. We could of course also adjust its thickness and combine them together. Then we can copy the handle with a locked access to the other side. We group the whole thing and combine it with a frame. Just to practice another time, let's create a unique component from this door. We then copy it and paste it into our 3D file. As you can see now, it appears as a new component. We could now change the color again. Sometimes it may not colorate all surfaces for some reason, so always recheck if you have colorated all the surfaces. Okay guys, this is how you could use objects from the warehouse and make them work for you to save some time. You're always free to create your own objects. Everything that is within SketchUp Warehouse can be used for any projects as long as you don't share the files with anyone else. And because I can't share this door with you, feel free to use another door from the warehouse or watch the next video where we will create our own Eden Springs front door. See you there! Hi everyone! Let's create our Eden Springs door together. We will begin by creating a new file. I have already designed my frame and applied the color of my choice to it. If you prefer, you can create the frame in your main file and then copy it into the new one, or simply work in your existing file. The choice is yours. To start, let's create a rectangle and push-pull it out to approximately 100 millimeters or about 4 inches. This will be your door thickness. However, feel free to select a different door thickness that suits your preference. Once you have created the door, make sure all surfaces and edges are selected within the grouping. If there's any issues, don't worry, you can undo with Command Z or Ctrl Z and try it again. Next, let's go inside the group and copy the color from the frame by holding down the command or key. Alternatively, you can select a different color from the color charts or use the spectrum of colors available, adjusting their darkness as desired. Now let's add the vertical stripes resembling VJ panels. You can choose the number of stripes you would like. For this example, I made 10 vertical stripes. Now let's do some quick math. If my door is 820 millimeters, which equals 32.28 inches wide, and each slim break between two panels is 10 millimeters, 0.39 inches wide, with 9 breaks total, the deduction would be 90 millimeters or 3.51 inches. This leaves me with 730 millimeters or 28.77 inches, which I then divide by the number of panels I would like to have, in this example 10. Each panel would be approximately 73 millimeters or 2.88 inches wide. Now let's create the panels. Copy the line and move it to the calculated distance. Duplicate the line to mark the slim lines in between. After that, we select the surface and copy it multiple times. Please consider the panel's width and the slim line width when moving it. If you prefer, use guides to assist you in the process. Select the vertical panel surfaces by holding down the Shift button and copy them to the back side of the door. You may need to reverse the faces if necessary. Now push-pull the slim lines to give them a more 3D shape. In this example, I push them for about 10 millimeters, which equals 0.39 inches. This should be efficient. By double-clicking, you can apply the same setting to the rest of this side and the other side as well. Congratulations, you have created a unique door. Let's move on to designing the half-moon door handle. This handle is quite large, measuring 300 millimeters, which equals 11.8 inches. It's helpful to start building from the ground up and visualize how to transition from 2D to 3D. Start by creating a circle with a radius half the desired handle size. Divide the circle in half using the line tool and remove the unnecessary half. Now push-pull it to the thickness you prefer. I chose 25 millimeters or 0.98 inches. Create another line with the same thickness inside the circle, ensuring it divides the surfaces correctly. Then push-pull this part out by, let's say, 25 millimeters or 0.98 inches as well. Finally, group the entire handle, rotate it to the correct position, and place it on top of the door. For accurate placement, consider that the center of the door handles is usually positioned about 1080 millimeters or 42.52 inches from the ground. Create a guide at this height, then select the midpoint of the handle and move it up. When it comes to the distance from the edge, a position of approximately 45 millimeters or 1.77 inches should work fine for this example door. Now let's create the handwritten letters to make it super fancy and Insta-worthy. But of course, I want to show you how to create extruded text mainly. Click on the text tool and open the font section. We will need it in just a second. Choose how wide you want your text to stick out. Then, I'm not sure if this is a SketchUp 2023 bug, but for some reason, right and center alignment are exchanged. So I write my text, choose my font height, and then you need to press Enter in order for it to apply. After that, I can select the font of my choice and then we place the text on our door. As you can see, text always comes as a component. If you don't want that, simply explode the file, remove unused components, and regroup it again. There you have it, a fancy extruded text on your door, looking great. Finally, let's group all the objects that belong to the door together and place it inside the door frame. If you forgot the handle on the back side, no worries, just click inside the group and copy it to the other side. Be sure to use your arrows to lock the axis for precise movement. Feel free to group objects or areas separately to avoid interference as you find useful. We could make a component from this door if we wanted. For instance, we would like to share this file with others in the SketchUp warehouse. We could include our names or our website. I will cover this in the next video. I hope you enjoyed this tutorial on creating your own unique door. You can either create the Eden Springs door as we did in this video, or challenge yourself by finding an inspirational image and recreating it using all the tools we have covered so far. See you in the next video. Hi guys! In the previous lesson, we successfully created our Eden Spring store. Now I would like to show you a quick and easy way to upload any files you created to the SketchUp warehouse. This will allow you to share your work with other designers and contribute to the growth of the SketchUp community. To begin, it's a good practice to create a clean, new file and include only the object you want to share. This ensures that when others download your file, they won't receive any unnecessary baggage. To upload your object, simply right-click on it and select 3D Warehouse. Then click on Share Component. This action will automatically open the SketchUp warehouse. Here, you can fill in details such as the title, a description, and you can choose a category that fits best to your object. There are several categories to choose from, so just browse through to find the most suitable one. For this example, I chose Interior Design and Residential. If you want your model to remain private, only accessible to you, you can enable the private mode before uploading. This way, the file will be saved in the warehouse and you only will have access to it, freeing up space on your computer. Once you're ready to launch, simply click Upload. The rendering process may take a few minutes, but once it's done, you will see a preview of your model and it will be available on your public page under Models. To find your uploaded file, return to the main page of the SketchUp warehouse and use the search function. For example, type in Eden Springs or Velika Homes and then click under Models. Here you can find all the files I have uploaded so far. You can now download them directly into your project. Keep in mind that the file format, millimeters or inches, doesn't matter when downloading from the SketchUp warehouse, as SketchUp will automatically adjust the file to your chosen template. Sharing your creations is essential for supporting and enhancing the SketchUp experience for everyone. By contributing unique objects, textures, or other resources, we can all benefit from each other's work and foster a sense of cooperation within the community. Let's continue embracing the spirit of sharing and make the most of the SketchUp platform together.